Hi students, this section belongs to your textbook section 2.4 in the conversion of binary, denary, and hexadecimal numbers. And we will start with the conversion between binary numbers and denary numbers first. And let's say if we have a binary number like this, 110101 base 2, then we have to convert this into a denary number. We can simply check out all the place value. This will be 1, 2, 4, 8, 16, and 32. We simply add up all those place values with the digit 1, and that will be our answer. So this will be 32 plus 16 plus 4 plus 1. And this amounts to 53 base 10. And it seems that this process is rather easy because we simply add up all those place values with the digit 1 when we convert a binary number to a denary. But what if we are required to do the reverse process? We have to change 53 base 10 into a binary number, and that will be a bit more difficult. And we start with the number 53 and then do a division, and the divisor is 2. Therefore 53 divided by 2 we have 26, and we have to beware of the remainder. We have a 1 here, the remainder is 1. And then we continue to divide this number, divide the quotient, in fact divide 26 by 2, and we have 15, and this time the remainder is 0. And then we continue the process. We have 1, 3, 0. And finally, we come up with the quotient 1 here. And therefore, our answer will be reading from the backwards, which is 110101. 110101 base 2. So let's take a look on one more example. Let's convert 13 into a binary number. Again, we start with the division, and the divisor is 2. Therefore 13 divided by 2 we have the quotient 6. The remainder is 1, and then we continue to divide the quotient by 2. So it's 0. And finally, we come up with the answer 1101. 1101. We read the answer from the bottom. Therefore, 13 base 10 equals to 1101 base 2. And in order to understand this method, we can actually see that this place value is 8, and this 1 represents 4, and this 1 represents the place value of 1. And we can see that 13 is actually the sum of several exponents of 2. This is 2 to the power 0, 2 to the power 2, 2 to the power 3. And actually, if we can break down a denary number into the components of the powers of 2, then we can easily write down its binary format. And for example, if we have 25, we can simply break it down into the components of 2, the powers of 2. We have 25, the largest powers of 2, which is less than 25, is 16, which is 2 to the power 4. And then 16 plus 9, and 9 can be broken down into 8 plus 1. And therefore, we have 1, 2, 4, 8, 16. That is 11001. And in fact, we can think of this binary number in terms of a box. And this is a box with 5 apartments, 劏房. And each box has a place value 1, 2, 4, 8, 16. So if we have 1 plus 8 plus 16, we simply put a 1 inside that box. 1, 1, 1. And then for the place value 2 and 4, we simply fill up with zeros. So our answer is 11001. And so, in order to make our method much easier, we can simply remember or record the powers of 2 in this way. We have 1, 2, 4, 8, 16, 32, 64, 128, and 256. And if we come across this Denary number, 73, therefore we can find the largest powers of 2 which is smaller than 73. Therefore we have 64. Plus 9. And 9, in fact, can be further break down into 8 plus 1. And therefore, we have a 1 in the box 64, 1 in the box of 8, and 1 in the box of 1. And then we fill up all those box, the remaining box with zeros. Therefore, this will be 1001001 base 2. And finally, to convert numbers between hexadecimal digits and Denary numbers. And again, we can apply the same method as we are doing with binary numbers. We have 23A base 16. And this A actually stands for 10. It contains the value 10. And its place value is 1. So this will be 1, 16, 16 square. And therefore, if we write this in the expanded form, it will be 2 times the square of 16 plus 3 times 16 plus 10 times 1. And therefore, we have 570 base 10. And to convert Denary into hexadecimal, and actually we need to do some sort of short division. But in fact, this method is rather stupid. In fact, we simply use a calculator to do the conversion. Key in 570 base 10 in the calculator, and then press the hexadecimal digit, and then it will return the number 23A.